Start with surface tension better. That is properties of liquids. Properties of liquids. First one is surface tension. Surface tension. Represented by letter capital T beta. Okay. So already define the surface tension beta. Surface tension is nothing but the two part of a liquid which has been pulled to each other with a force. Like say for example, on a liquid surface generally, on any spherical part, like say for example, this is your spherical part, and in this one, say for example, liquid is been filled like this. Okay, so if I draw an imaginary line on this one like this, if I draw an imaginary line on this one, and there is a force exerted from this side, this is your F, and there is a force exerted because of this side of liquid, that is nothing but F. This force exerted of this per this unit length, the length of this imaginary line, I'm taking it as a L. The force exerting on this surface, this force per unit length is called as of your surface tension beta. And you remember that the surface of a liquid will behave like a stretched rubber sheet. Okay.
Yes.
So right here, right now, surface of liquid behave like a stretched rubber sheet, Okay, you might have been seen, say for example, on the surface of water, generally the mosquitoes are able to walk. The reason for that, when the mosquito is exerting the force on the liquid is not getting break the bond. So the force exerted by the leg of the insect onto the water is not having capacity to break the bonding of the water molecule. That is the reason the water molecule will slightly get compressed, so that the mosquitoes are able to walk on the surface very easily. That is the reason the surface of the liquid will behave like a stretched rubber sheet particulation. Is that clear?
Yes, sir. Sir, and that too, sometimes with high speeds, even human can also like go on water.
Yeah, human. If you see in the movies of the Chinese, or even if you throw a stone, if you throw a stone with certain velocity, it will try to strike the upper surface of the liquid and try to move the other part. Isn't it? Some what do you call that? Lizards also will have a capacity to walk on the surface of the liquid for certain distance.
Yes, sir.
Because they exert the force on the liquid for in such a fast way that the liquid doesn't have the time to break. Is the reason they're able to move very easily from one point to another point.
Okay, sir.
Clear?
Yes, sir.
Sure. So now I can say that the two part of a liquid pull each other with a force. So this part of a liquid and this part of the liquid are pulling towards each other. So that pulling force per unit length is called as of your surface tension. Is it clear? So I can write here.
Yes, sir.
Two part of your liquids. Two part of your liquid pull each other. Pull each other with a force capital F, isn't it? So this part of a liquid is pulling with your F, and this part of a liquid is pulling with your F, isn't it? So surface tension is defined as this force per your unit imaginary length is called as of your surface tension. Is called as of what? Surface tension. So surface tension is equal to how much for me? T is equals to your F by L. Or else I can write here force will be equal to your surface tension into your length. Surface tension into your length of the liquid. Is it clear?
Yes, sir.
Is it? So that will be the force form. So surface tension is equals to your force per your unit liquid. Clear?
Yes, sir.
Next one. Very important point. Thin film, or we can say a soap bubble. Soap bubble. Okay. Thin film or soap bubble always has two surfaces beta. Thin film or soap bubble will always have
Two, sir.
surfaces. Okay.
Yes, sir.
So if just in a drop, in a drop, there is only one surface, like water drop. Okay. So soap bubble or a thin film always has how many surfaces, beta? Two surfaces. That is the reason the force is represented by the formula F is equals to T into L into 2. Okay. This is for what? Soap bubble.
Soap bubble or thin.
For a soap bubble, force will be equal to T into L. Is that clear?
Yes, sir.
How is that possible? You see here right now. Like say for example, if I take this one as a rectangular sheet of paper, beta, or like a frame, and it is having a sliding wire in this one like this, a sliding wire. Okay, a small wire is been kept. When you immerse this one into the soap solution, a small layer has been formed on the front and back. Like say if I take a slate, you remove the inner part of a slate and dip it into the soap solution. Will you see the film formed on either side of that frame, beta?
Dipping it in.
Are you able to get me?
No, sir. I didn't
You
understand that.
see, this is your slate.
Yes.
The slate has the middle one, the black portion to right.
Yes, sir.
So you remove that black portion. So now this will become a frame like this,
Yes, sir.
a small frame like this, isn't it?
Yes, sir.
Dip this one into the soap solution.
Yes, sir.
If you dip in the soap solution and remove, you might have been seen in the generally kids will be playing with your soap bubble
Yes.
with a ring and immersion soap bubble. A bubble will be formed from that one when they blow.
Yes, sir. Yes, sir.
Isn't it? So when this frame has been filled into the soap bubble, a frame is one surface is on this side, another surface is on the back side of that.
Yes, sir.
Isn't even if you take with your hand, when you go for your hand wash with your Dettol or with your soap and you
Yes,
rub
sir.
it,
Putting your hand like
open it, there will be a
together.
soap bubble
Yes.
formed in that one.
Yes, sir. It is
So
formed.
you will be seeing the two surfaces, one towards your side and one other side of your
Other
hand,
side.
isn't it?
Yes, sir.
That means the
Yes,
soap
sir.
surface, it always has two surfaces for this one, beta. And for this one, if I'm attaching a small weight for this one, there is nothing but of your M into G. So this weight will be pulled in this downward direction, but this soap solution will try to pull and try to make the minimum surface area. So soap surface will be exerting the force in the upward direction. So in the equilibrium condition, I can say that this force will be equal to your M into your G, very small. So this soap
Yes, sir.
solution, whatever you're trying, this will always try to have the minimum surface area. Because of that one, this soap solution will try to pull back again to the original body to have the minimum surface area. So this soap solution means what is the answer right now? I can write for this one, beta. This will be equal to your 2T into your L is equals to your M into your G. Can I write like this?
Yes, sir.
Isn't it? For what? For equilibrium condition. So whenever it is in equilibrium condition, F will be equal to your mg or 2T into your L will be equal to your M into your G. Is that clear?
Yes, sir.
So thin film or soap bubbles will always have how many surfaces, beta? Two surfaces, whereas a drop there is only one surface. So for the soap bubble, F is equals to T into length of that frame into your 2. Is that clear?
Yes, sir.
Sure. One more point. If I'm talking about your glass plate, generally when you give your blood for your blood testing, they'll take the drop of your blood and try to keep between the two glass plates. Have you seen that one?
Yes,
have you
sir.
seen any time? Isn't it? Or else you take between two glass surface. If I take a drop of water and come and keep the another glass plate on that one, the drop will be trying to get spreaded on that one. Like say this is your plate, a glass plate, and here a liquid drop is being kept on this one. On this surface, again I'm taking one more plate like this,
Yes,
and I
sir.
kept on this one. So what happened? This will get dispersed like this.
Yes, sir. It'll move. Yes, sir.
Okay. So such type of a glass plate I'm taking right now. So if I'm talking about your glass plate, see here what is happening. So I'm drawing the free body diagram for you. So this is your glass plate. Okay, and liquid is been trapped in this one. And thickness of this one is, say for example, D. D is nothing but here what, beta? Thickness. thickness of your film of your water. Okay, and this
Yes,
one
sir.
is your glass plate, which is having the area of cross section of your capillary. The force required to separate these two glass plates will be equal to how much? Force required to separate two glass plates. Two glass plate is F is equals to 2T into your A divided by your D. This is the force. F is equals to how much for me? 2 into T. What is T here, beta? Surface tension. A is area of cross section, and D is what? Thickness. Thickness of the
Yes,
film.
sir.
Liquid is being filled between two glass plates. The force required to separate that one is given by the formula F is equals to 2T into your A divided by your small d. Is it clear?
Yes, sir.
Sure. So these are the two important formulas you need to remember in this one. The first one is surface tension. T is equals to F by L. A thin film or soap bubble has the two surfaces. A liquid drop has only one surfaces. So whenever we are talking about this liquid, what do you call that one? Soap bubble, F will be equal to how much for me? Surface tension into length into your 2. Okay, in equilibrium, F will be equal to the weight which has been attached to that one. So 2T into your L will be equal to weight. So for glass plate, the force required to separate the glass plate is given by the formula F is equals to 2T into A divided by A. So A is nothing but here what beta? A is your area of your cross section. Area is your area of cross section. D is nothing but what beta? Thickness of your film. Okay, na?
Yes, sir.
So next.
A is area of cross section, T is surface tension, and D is
T
thickness
is
of film,
surface
right?
tension and L is nothing but length, isn't it? So T is your
Yes, sir.
surface tension, A is your area, D is your thickness.
Thickness. Yes, sir.
Okay, next one, and very important. Try to understand this one better. Force required to pull a body from liquid surface, from your liquid surface. Okay, na? Force required to pull a body from your liquid surface. Have you anytime felt like this one better? Like say for example, whenever you go for your what do you call that one, shower or something, like you try to do this one, you try to fill the water with your in your bucket completely, and take your hand and
Yes,
completely make it completely fix all the fingers very tightly and keep it on the surface of the water very slowly,
yes, sir.
and you try to remove that hand slowly in upward direction. Will it come easily upward direction, or will you require certain amount of force to move in upward direction?
Sir, some force, sir.
Some force, because the liquid surface down, what is happening is it is trying to get attracted to your upper surface. So there will be certain sort of a
Yes, sir.
force of cohesion. So if you keep your fingers all the tight and keep on the surface of water, and you try to slowly remove the hand in the upward direction, you can't remove very easily. The liquid which has been attached to your water will also get rise along with that one slowly in the upward direction, isn't it?
Yes, sir.
Or else you can even do something like you take a glass you plate, this or not glass plate or any steel plate in which you eat. You keep that one very slowly on the surface of the water in which water is being filled in a bucket, and you try to move that plate upward direction. Will it move very easily, or along with that one the water is also moving in upward direction?
Sir, once.
See, this is your bucket, Nana.
Yes, sir.
Listen, this is bucket full of your water.
Yes, sir.
On a Mintla, we generally eat in a plate something like this, small
Yes,
plates
sir.
like this. So
Yes, sir.
now this is, do you take this plate and keep it this one on this surface very slowly like this? Will it
Yes,
float
sir.
or not?
It will float, sir.
Isn't it? Now you try to remove this one upward direction with the force F. What happens? This amount
It's
of
kind
liquid
of
which
stuck.
will also will come in the upward direction along with that one.
Yes,
Lift
sir.
it very slowly,
Yes, sir.
not very suddenly, isn't it? So
Yes,
what
sir. It will
happens?
come, sir.
This small amount of liquid is also trying to come in the upward direction. Will it come or
Yes,
not?
sir. It will
Is it?
come,
Have
sir.
you imagined? You can just do this imagination today also in your home. So just keep a plate in front or in on the bucket and try to move it. Along with that one, the water will also be try to come in the upward direction.
Yes, sir.
Now we are talking about how much amount of force is required to bring such type of your bodies and upward. So let us try to talk the first one. I'm talking about first one is like say for example, a square plate. Okay. So for square plate, I'm keeping the square plate on the surface of water. Okay. This is your square plate. Okay, this one is, say for example, a square plate. Okay, na?
Yes.
Now this square plate is been kept on the surface of water, and I am pulling it in the upward direction. So from here I have taken one button. Okay, I have taken one button here right now. Here one button, and here one button is attached. Here one button is attached, and here one button is attached, isn't it? And it is been kept on the surface of water very slowly. Okay, there is completely water like this. And middle one is completely a solid beta, because we are talking about a circular, a square plate.
Yes.
What do you mean by square plate right now? Square plate means this one is totally a solid, like this. Okay, na?
Yes, sir.
Now for this one, we are attaching a thread right now here. We are attaching a thread right now here, like this. This thread is attached to this one. This thread is also attached to this one. And we are applying the small force to move in the upward direction.
Okay.
Slowly. So weight of this one, of this plate, is actually acting in this direction, with a downward direction. That is
Downward,
nothing but
okay.
of your M into G. Force is in the upward direction, isn't it? So what is the total
Yes.
length of this one? L, 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 L. That will be equal to how much for me, beta? 4L. So force
Sir.
required will be equal to how much, beta? F is equals to 4T into your L plus of your M into G. Because surface tension is acting in the downward direction,
Down.
Mg is also acting in the downward direction. Clear?
Yes, sir. Clear.
So if I am taking a square frame, what will be the answer? Can you tell me? For your square frame. Square frame. Square
the
frame has how
center
many
is-
surfaces? Two surfaces.
Yes, sir.
So for
So
this
four-
one, what I can write here right now?
2,
F will be equal to 4T into your L into 2 plus weight of the body, that is mg. That means this will become for me how much? 8T into your L plus of your M into G. So this will be the force for the square frame. Is it clear?
Yes, sir.
Isn't it? Let's see, one more condition.
Sir, but for the square frame, the center is
Center is a center of mass only. Because if for the ring, we don't have the mass at the center, but still the center of mass is acting at the center only, na?
yes, sir. Yes.
Like as a play, what do you call that, slate?
Yes, sir.
Isn't it? A photo frame.
Yes, sir.
Isn't it? Something like that. The next one is condition for needle. For needle not to sink. If we take a small needle beta and attach the grease to the lower part and slowly keep on the surface of water. Okay.
Yes, sir.
So when you say, for example, a needle like this, a small needle like this. This is the spherical surface. Okay. So this is the spherical surface of this. And you are keeping it in the surface of water like this. Okay. It is floating on the surface of water like this. Okay. It is floating better. This part is running backward direction.
Okay.
So when it is being floating, the weight of this part of the spherical region will be acting in the downward direction with mg. This part of a liquid is exerting the force acting on this one, F in this direction, and this is also exerting the force on this one, F in this direction. Theta is very, very small. So surface tension acting on that one will be equal to how much beta? Surface tension will be equal to F is equals to T into L here, and here also F is equals to T into L. Actually, it is making an angle theta here. This theta is lesser than 2 degree or 3 degrees. So theta is negligible. So that will be equal to how much beta? F is equals to TL in upward direction, and F is equals to T into your L in the upward direction. That means
Yes,
I can
sir.
write 2T into your L will be equal to weight of the body. That is nothing but equal to your mg. So in order to not to sink in this one, the weight of this one must be balancing what beta? Surface tension force in the upward direction. That is 2T into L must be equal to your M into your G. Clear?
Yes, sir.
Because this surface tension is because of this liquid, na? So this is exerting the force along the tangential this surface, and it is making a small angle beta. Angle is very, very small. That is the reason we are neglecting that one. So the upward force will become how much for me? T into L, and this side this will become for me T into L. That means the total force will be 2T into L. That will be balancing the weight of the body. That is nothing but for mg in the downward direction. Is it clear?
Yes, sir.
So we got only one formula here right till now beta. That is about your surface tension formula. That is, surface tension formula is how much per meter? F is equals to your T into your L. If it has two surfaces, you multiply it with 2. It has one surfaces, you multiply it with your 1. Okay, na?
Yes, sir.
Sure. Next one. This is something very important for us. That is surface energy. Surface energy. Represented by letter U. Okay. So surface energy is nothing but equal to your U is equals to the product of surface tension into area of cross section. Okay. Surface energy will be equal to what beta? T into area. What is T beta? T
Surface tension.
surface tension, and A is your surface area.
Area.
A is your surface area. For sphere, it is 4 pi into r square. Isn't it? So
Yes,
work
sir.
will be equal to how much? Work done will be equal to change in your surface energy. That will be equal to T into your delta A. So work done can be calculated by the formula delta U. The delta U is equals to surface tension into your area. So this can also be written as of your delta U is equals to your surface tension into area. Area can be written as of your final area minus of your initial area. So surface energy or work done will be equal to how much beta? Surface tension into your change in area. That is nothing
Area.
but 2 minus of your A1.
Okay, sir.
Okay. So now thin film or soap bubble has how many surfaces beta?
Two,
Two
sir.
surfaces. And drop has how many surfaces? One surface. Isn't it? Now see,
Yes, sir.
if I'm talking about your soap bubble, listen it very carefully. I'm having a soap bubble of radius, say for example, R1. Okay. Now I'm increasing this one to your R2. Okay. Then what is the work done to increase this one? Initial surface area of soap bubble how much beta? R1. Now you're increasing it to your R2. That means the work done will be equal to what beta? T into your change in area will you write? That will be
Yes,
equal
sir.
to surface tension into area will be equal to how much? A2 minus of your A1. Area of sphere is how much beta? 4 pi into R square.
Yes, sir.
So this will become for me T into, this one will become how much for me? 4 pi into your R2 square minus 4 pi into your R1 square. Can I write like this? So work done will be equal to T into 4 pi will become common for me. This will become for me how much for me? R2 square minus of your R1 square.
Yes, sir.
So this will be the work.
Okay.
W is equals to T into 4 pi into your R2 square minus of your R1 square.
Carbon.
Isn't it?
Yes, sir.
Isn't it? Now see, if I'm talking about for soap bubble has how many surfaces?
Two surfaces.
Yeah, as soap bubble has two surfaces. So this work done will be equal to how much beta? T into this 4 pi into your R2 square minus R1 square multiplied with your 2. So work done will come out for me how much? 4 into 2, that will be 8. This will become for me your T into your 8 pi into your R2 square minus of your R1 square. Is it clear?
Yes, sir.
Isn't it? So for the soap film, you just multiply it with your into 2, that will give me the answer. If it is a drop, the answer will be equal to this one. This is for what? Drop. Single
Yes,
drop,
sir.
isn't it? So if a drop is increased from your R1 to R2, then work done will be equal to T into 4 pi R2 minus R1. If it is a soap bubble, it will be your 8 pi into T into your R2 square minus of your R1 square. Is it clear?
Yes, sir.
Chalo, next one. And very important, this one, beta. Splitting of bigger drop. Splitting of your bigger drop or small drops combine to form big drop. Okay, na? So if I'm talking about your splitting of your bigger drop and small drops combine to form a big drop. Okay, I'll take the first one. What one? Splitting of a bigger drop. Like say I'm having this one as of your bigger drop beta. And this one is your radius of capital R. and this is being splitted into your n number of droplets. 1, 2, 3, 4, like that. How many? N drops. Okay, now.
Yes,
So what
sir.
is happening to the area?
It is increasing.
Yeah, area is increasing. Initially, this was only the area. Now, small drops are covering larger area. Na? So, this is area is increasing. Now, what happened to the volume? Volume will be constant or different beta?
Sir, it'll increase, right, sir? With the...
No, no, no. Volume should be constant because if I bring back all these drops, it should give me again the original drop.
Okay, yes, sir.
Like say if I'm having 10 rupees note and if I'm making a chain of 1 rupee, if I get back like 10 rupees coins and give back again, so will I get my 10 rupee note or not? Isn't it? So if I'm having one 10 rupees note beta or 100 rupees note, and I made a change of your 10 rupees, 10 rupees, 10 rupees, 10 rupees. So if I
Yes,
add
sir.
all the 10, 10, 10, will I be getting 100 or will it be lesser than that one?
It'll
100 only, no? So what is
yes,
volume? So what is happening to this one? The
volume.
bigger
It
drop is
remains
being
same,
taken
sir.
out into a smaller. Volume is remaining for me
Same,
constant.
sir. Constant.
Yeah. So volume is constant. If volume is constant, means volume of bigger droplet 4 by 3 pi into your capital R cube must be equal to volume of your small droplets. How many droplets there are? N into volume of smaller droplets means 4 by 3 pi into smaller cube. Each one is having a radius of, say, for example, smaller. Okay. 4 by 3 will get cancelled. So R cube will be equal to your N into your smaller cube. So if I cube on both the sides, so R will become how much for me? N to the power of 1 by 3 into your smaller. So this will be the relation between capital R and smaller. So capital R is equal to N to the power of 1 by 3 times of your smaller. This you have to remember it.
Okay, sir.
When a bigger drop is being taken into smaller drop, radius of the larger drop will be equal to N to the power of 1 by 3 times of your smaller. Clear?
Yes,
So
sir.
what will be the work done in this one, beta? What will be the work done? Or I can say change in surface area. Or change in your surface area. Kitna hoga batao? So how much it will be better? Delta U will be equal to, or we can write W is equals to T into your A2 minus of A1. Isn't it?
Yes, sir.
So W is equals to T. What is A2? A2 is large or A1 is large? Initial area is large or final area is large?
Sir, the final, sir.
Final, na? This one is
Yes,
initial
sir.
area. This is your
Yes, sir.
initial area, isn't it? This is your initial area. This is your final area. Final
Yes,
area
sir.
is more, na? So how many
Yes,
droplets
sir.
like that? So it is n times of your A2 minus of your A1. Can I write like this? So W will be equal to T into, this one is n into, this is 4 pi into your small r square minus 4 pi into your capital R square. So this work done will be equal to T into your 4 pi will become common into, this one is n into small r square minus of your capital R square. Can I write like this?
Yes.
Isn't it? So work done to release energy is when a bigger drop is being converted into a smaller part, energy is released or absorbed. Okay,
Yes, sir.
I'll tell you that one. Okay, anyhow.
Yes, sir.
So you know now the value of capital N beta or smaller. You can write everything in terms of your one single terms. I can write everything in terms of your smaller droplet. W is
Yes,
equals
sir.
to 4 pi into capital T into, this one is n into small r square minus capital R value. How much I got? N to the power of
Into the
1
power
by
of
3.
1 by 3.
So this one
Smaller.
is n to the power of 1 by 3 into smaller. I can write this one as whole square. So that will
Yes,
become
sir.
how much for me? 4 pi into r square, and r square will come here right now out. This is surface tension T into your n minus, this will become for me how much? N to the power of 2 by 3.
Yes, sir.
Can I write like this?
Yes, sir.
This will be the work done. Clear?
Yes, sir.
So depending upon smaller or capital, I can write the answers for that. Is it clear?
Yes, sir.
Chalo, next one. Keep it a star mark beta. See here. Whenever a bigger drop gets converted into your small drop, okay, energy is released or absorbed. Energy absorbed
Yes, sir.
because temperature falls.
Okay.
Temperature falls. Surface energy will be more. So when surface energy is more, temperature will fall. Like say, for example, when you take it a cup of tea, if you are having it in your glass and if you keep the same tea in your saucer,
Yes,
will
sir.
it get cooler, easier or not?
Yes, sir. So the
Is it
temperature is
why?
falling.
Because
Yes.
the area is larger.
Yes, sir.
So more the area, that means temperature is falling. When temperature is
Yes, sir.
falling, means energy is being absorbed. Who is
Yes,
energy?
sir.
Who is observing the energy? Surrounding.
Yes, sir.
Is it? That means from the bigger drop, small drops are absorbing the energy. Is it clear?
Yes, sir.
Next one. If a small drop is getting converted into your big drop, isn't it? In this one, what is happening? Energy is released. Energy is released. Why? Because temperature is increasing or decreasing. Temperature increases because the smaller one, na?
Yes, sir.
If you're having the cup of tea in your small saucer or in a bigger saucer, the smaller one will having more
Temperature is
temperature compared to the
increasing.
bigger
Yes.
one. So
Yes, sir.
small drop, when it has been converting into big drop, energy is
Energy is
released.
released.
When energy is released, the temperature will be increasing. Is it clear?
Yes, sir. Yes, sir.
Sure, very good. Okay. So this was about your little bit introduction related to your surface tension parts. I hope you got a rough idea related to surface tension better. So what is
Yes,
the
sir.
surface tension? Surface tension is force per unit length, or F is equals to T into your L. So the soap bubble has always two surfaces, and the liquid drop always has only one surface. Force required to pull a body. This one is very clearly given in your Sri Chaitanya material better. If you have your material, you try to open that one and try to see in the first page itself. There are
Okay,
6-7 cases which have been given for elliptical, for circle, for annular ring of having different radii. You can just give a study once and try to understand that one. If you're not understanding, you please let me know. I'll try to help you. Isn't it?
Okay,
The next one is nothing but of your surface energy. Surface energy is equal to T, because see, the derivations of all this one are not required. That is the reason I'm not doing the derivations. So
Okay,
direct
sir.
results are only very important for complete your examination right now, because as you have completed the first year, so you must be equal to surface energy formula. That should be striking in your mind. It should be the product of your surface tension into area of your cross section. For
Yes,
sphere,
sir.
area of cross section is 4 pi into your r square
R
pi.
square.
And what is the relation between Kepler and small r means? Kepler will
R
be
is
equal
equal
to how much per
to
meter?
10 to the power of 1 by 3 smaller, sir.
Yeah, so that values we need to remember for that. So this one is your relation. Clear?
Yes, sir.
Sure. So that was about your basic conditions which have been told you. Actually, this chapter is also very big and very theoretical chapter beta, and very minute things are very much required. And purely for examination, it is
Okay,
again a
sir.
formula based. Purely formula
Yes.
based on some periodical questions, you have to do it out. So you try to do the theory today from your this notes. You can read it first. That's more than enough again. Or else you can study the summary from your college material. The last
Okay,
there will
sir.
be summary points, no?
Yes, sir.
ఎప్పుడైనా ఓపెన్ చేసావా నీట్ మెటీరియల్ ఒకసారి ఓపెన్ చేయి
Yes,
అందులో
sir. Jason, sir.
లాస్ట్ సిరీస్ చాప్టర్ దెర్ ఈస్ అ సమ్మరీ సినాప్సిస్ అని ఉంటాయి ఆ సినాప్సిస్
Yes,
వరకు
sir.
దట్ విల్ బి మోర్ దర్ ఇనఫ్ ఫర్ ద what you call that revision at this moment.
Okay, sir.
Don't go for the derivations. Okay na? And today I'll try to send you one assignment on your elasticity beta. You try to complete it by today night.
Okay, sir. Yes, sir. I've seen those
Elasticity
questions, sir.
అయిపోయిందా? Try to
Yeah.
do it today, complete the assignments better, whatever given you, and try to revise it and write one exam
Okay,
on
sir.
the 45 questions tomorrow. Have you downloaded this one beta? Wait.
Yes, sir. I downloaded, sir.
Okay. Then you open that question paper in the squid and try to tick the answers in that one and send me back.
Okay, sir.
Okay. Na? So you got to
Yes,
see
sir.
how I'm using the squid only. You are getting an idea how to that one. So you can just add the
Yes,
pages.
sir.
Isn't if you're doing the solutions, you go for the page actions. You can insert a page there and you can do the derivation there. Have you got a stylus with you?
Yes, sir. I have it.
Is it working?
Yes, sir. It's working, sir.
It's good, huh?
Yes, sir. It's fine. It's
Download
working.
it where, in mobile or in the iPad?
Sir, mobile only, sir.
Which mobile?
Sir, there is this LG stylus.
Okay,
The
LG.
mobile
Have you
name is
bought new
only.
one or is it the old one only?
It's kind of old only, sir. My mom's old phone.
Okay, fine. Is it working there?
Yes, sir. It's working, sir.
Perfectly. Okay, then just today you download that question paper in that one and you try to do that one, keeping 1 hour, and try to tick the answers in that one only.
Okay, sir.
You don't waste the time again buying separate basically. So try to complete there itself. It will be helpful.
Okay, sir.
Okay. How the chemistry sir is teaching beta on board or smart board?
Uh, Actually, starting like till the time before I got COVID, he taught on board only, sir.
Hmm.
but now he's using his laptop only.
Acha.
Whiteboard, yes, sir. Word one.
Acha. Whiteboard is using, huh?
Yes, sir.
Okay, okay. Okay, chalo then. Okay, na?
Yes, sir. Yes, sir. Thank you, sir. Bye, sir.